So you need finite state machines for your AI in Unity, but you don't know the best way to implement them. You've come to the right video. In this guide I will show you the 3 main ways people use for implementing finite state machines in Unity, and even go over my own method step by step. Let's consider this example. A skeleton enemy character has 3 states. When nothing's going on, he's just idling. When he's idling and the player comes near him, he will draw a sword and go into an attack state. And when he's idling and his health is below 30, he will go into a healing state. The first way is using Unity's built-in animator. So first you attach an animator to your character, and then you create a new animator controller. Open up that controller and then copy the states and transitions from your FSM into the controller. Then you create a bool for each transition, which will determine if the transition is triggered or not. After that, create a behavior script for each state, which will handle all of your FSM logic, AI logic, and character behavior. Since not every state of your FSM will have its own animation, or your AI won't have animations at all, this approach will make your project unnecessarily complicated. Also, this approach isn't very clean and doesn't scale well. Just don't use it. So let's take a look at the state pattern. The state pattern is state of the art in software engineering, and it's best known for giving you the ability to manage complex finite state machines at a large scale. The basic idea of the state pattern is that each of your states has its own class, as well as another class called your FSM controller, which will be your main FSM class that manages all of your states and the logic behind them. So everybody has their own way of implementing the state pattern, but in this guide I want to give you the most general way I can think of, so it will be the most useful for you down the road. First, we create a new class for our FSM controller. Then we create an abstract class called base state, which all of our concrete states will later inherit from. In our abstract base state, we will make methods for each transition condition, as well as a tick method, which will be like an update method for our state. Then let's go back to our FSM controller, add an attribute there for your current state, and also make each transition condition a method there. Okay, after that, create classes for each of your concrete states and make them inherit from your abstract base state class. Now we can create public attributes in our FSM controller for each of our states and create new instances of the concrete states in our FSM controller constructor. And don't forget to set your current state initially to your starting state. So now let's go back to our FSM controller tick method. In the tick method, check for each of your transition conditions if it's fulfilled or not with a simple if statement. And if it's fulfilled, call the method of your FSM controller for that condition. For the standard implementation, you can just let the method of your FSM controller call the corresponding method of your current state. But if you have a more complex finite state machine, you can add more logic here if needed. And then in your concrete states, you basically handle the logic for your character in that state. And in the end, don't forget to set the new state of the controller to the state you want to go to. Of course, you will also have transition conditions, which will do nothing for that state, so you can just return there. So I know we could obviously simplify the implementation for our case here, but I wanted to give you the most general way of implementing so it will hold up for all of your implementation needs later down the road. However, with the implementation out of the way, I still have some criticism for this pattern, since it's not always as loosely coupled as I wanted it to be, and it really creates a lot of files and classes for your project, which can be quite overkill for small projects, even though it's the best approach for big finite state machines and big projects. So I have not used the state pattern in any of my projects before, since it would have always been overkill so far, which actually brings me to my own implementation of the finite state machines. So this is the method I use for implementing my finite state machines. My state is basically a class that has an entry action, an update action, and an exit action. And my transition is a class which has a transition condition, action when it's triggered, and a target state. The actions I just mentioned are references to methods or functions in your C# code, which will then be executed when needed. And the condition of the transition is a reference to a method or function which returns us a Boolean value. And in the end, transitions and states are brought together by another class, which will just be our finite state machine. And the finite state machine then gathers the actions that need to be executed and executes them, while also managing the FSM logic. So with this method, we can save ourselves a lot of classes and writing code, because we can always just reference the functions we have already written. Okay, with the basic idea out of the way, let's jump right into coding. So first things first, I will also upload this code on GitHub. If you just want to download it, go ahead. Okay, so now let's implement our finite state machine. Firstly, I'll create a folder for this, just call it finite state machine. Our finite state machine consists of 3 classes. Firstly, our state, which I'll call FSM state. Our transition, which I'll call FSM transition. Yup. And lastly, our finite state machine itself. Let's start by implementing the state. Go ahead and delete Unity, the Unity reference. We don't need that. We also don't need this, and it's just a normal class. So first we want a list of transitions our state has. Just create a list with FSM transition called transitions. Then we want 3 actions. Firstly, our entry action. So this isn't imported by standard, so just import it using system. We also want an update action and an exit action. Let's write our constructor. We will just take our actions as input parameters and save them for later. Okay, that's actually everything for now. Now let's come to our transition. We also don't need Unity engine here, no mono behavior, and no standard methods. Okay, first we want a private func bool. Just import this the same way we did before. And what this is just a reference to a function that returns us a Boolean value, as opposed to action, which we used before, which is just a reference to a method or a function that returns void. So it returns nothing really. Call this condition. Then we want a public FSM state, which will be our target state. And we want a public action, which will be the action that is executed when the transition is triggered. Oops. Also write a constructor for this. So public FSM transition, func bool. This will make our life easier later down the road. Okay, then we want a method which tells us if our transition is triggered right now. So we need a bool value returned from that method, and I'll call this method is triggered. So we'll firstly check if condition is null. Then we just return true, so this will be always triggered if there's no condition specified. Else we'll just return condition. Remember, our condition is the actual reference to the method, which will be then called, and the return value of our method will then be returned here. Okay, so let's go back to our state and give us a way of adding a transition to our state. You can call this method add transition, but I like calling it when, just for purposes of being more natural to say. So public void when, which will basically take in all the parameters needed for a transition. So condition, a state, which will be our target state, I'll just call it T state, and an action, which I'll just call A. Then just create a new transition, T, cond, T state, and A as input parameters. Then add our newly created transition to our list of transitions. So transitions.add T. And we're done. So now let's implement our state machine. Firstly, remove Unity engine. just like before. Okay, we need a private list of states which our state machine has. A private FSM state, which will be our starting state or initial state. Also a private FSM state, which will be our current state. And then I like creating a constructor, which will just take in our initial state. So this dot initial state equals initial. Then let's add some methods for adding states. So firstly, create a method called addState, which just takes in an FSM state and adds it to our list of states as. And then I like having a method for adding multiple states at once, because we will need this later. So we can use the params keyword for that. So what the params keyword does is you can later call this method with as many parameters as you like. So we will later use this method to call add states with state 1, state 2, comma state 3, comma state 4, and so on. And it will give us an array called state array in our case, which is just an array of all the parameters that were given to this method. We will then use a for loop to add all of these states to our list of states, and call add states for state array position I. Let's implement our logic for our finite state machine right now. We firstly want a private FSM transition, which we will call triggered transition, and we also want a private queue of actions, which we will just call actions. Upload that reference. And in this queue we will store our actions which need to be executed and then execute them. Let's implement our update method, which I will call tick method. And this will return us a queue of actions, just like up here. So each update of your character, you will call this tick method to just update the finite state machine, and just set our trigger transition, which we just created, to null. Then for each FSM transition in current state dot transitions. In this loop we will go over each transition of our current state and check if it's triggered. And if we find the first transition that is triggered, we just break here. So if transition dot is triggered, first set our triggered transition to set transition, and then break the loop. Then we want to do some stuff if our triggered transition exists. So if a transition is triggered. Okay, firstly let's grab the reference to our target state, which is just triggered transition dot target state. Then we want to add actions to our queue, which we actually haven't defined yet. So just define this public void, or private void rather, add action, action A, if A unequal to null. So not every transition needs to have an action, or not every state needs to have an entry action, and so on. So we can just ignore some actions. So just add this to our queue. So this dot actions dot enqueue A. If you don't know what a queue does or how it works, how you can add stuff there. So I assume most of you know how a queue works, but if you don't know yet, just go up, look it up real quick and come back to this video. I can't really explain it concisely right now. There's probably better videos online which tell you what a queue is. Okay, let's go back to our tick method. So add action, first current state dot exit action. Then add the action for trigger transition, add the action for our target state, its entry action to be specific, and set our current state to the target state we just got from the transition. Else we want to update our current state here, so we want to execute the action, which is the update action of our current state here. So to add action current state dot update action, and then we just want to return our actions here. I actually like returning our actions here and having them being executed in a separate method, since it will give us more flexibility on what we can do with the actions, like saving them for later or simply executing them, logging them in console, whatever. That being said, we just need a method which will execute our actions. The way this works with functional style programming in C# is that you can actually have this part of executing a reference to a function in every part of your code, but I like having the method in my finite state machine just for reasons of having a better overview. So okay, let's firstly check if actions equals null, then we just return. This doesn't really happen, but somehow it does happen. I don't know, just don't ask me, just implement it. If anybody knows what the bug is in my code, write me or create a pull request on GitHub. Then while our actions count, so the length of our queue is bigger than 0, we want to firstly get the action, which will be a equals actions.dequeue, and then just a and then the brackets, which will execute it. Yeah, two things I forgot in our finite state machine. We need to set the initial state to our current state to our initial state, and we also want to add the entry action of our initial state to our actions queue. That's actually all from the finite state machine. Okay, lastly, I want to show you an auxiliary class you don't need for your finite state machine to work, but it's rather useful to have it. And this class is a TimeCondition, which just is a condition you can use for your transitions that triggers after a certain amount of time, and you will probably need this for a lot of your AIs. So let's create the TimeCondition, open it, just like before, don't do this, remove this, and there we go, sweet. Okay, so we want this transition to trigger after a certain amount of time. So we firstly need a date time, which will be our starting time. Yeah, just implement a system or use system. Then we need a private float, which will be our time limit, and a private bool, which will tell us if the condition is fulfilled right now. So and we will set it to true. I'll explain this to you later in the code. Then just create a constructor, just like before for everything else, with just the time limit. Okay, then we just need one more method, which we'll call isFulfilled. So first we want to reset the condition if it's already fulfilled. That's why we needed the condition to be fulfilled up here. So I'll comment reset here. If fulfilled, start equals datetime.now, so reset it here. Fulfilled equals false and return false. And this is the part which actually checks if it's really fulfilled. Okay, so if datetime.now, which is our time at the moment, minus our starting time, this will give us a so-called timespan object. So we need the brackets here. In the timespan object, we can get our total seconds, which are just the seconds which have passed between start and now. So the time difference in seconds, basically. And if those are bigger than or equal to our time limit, set fulfilled to true and return fulfilled. We could just return true here, but this way we won't have any errors from the compiler. That's actually it. Okay, on to the example from earlier. Let's set up the finite state machine for it. I usually just set up my state machine in the start method at the beginning. Firstly, we will need a new state for each of our states. So we have a FSM state called idle, heal, and FSM state attack. I've already defined some methods down here. They wouldn't really add any value to our tutorial right here, so just look at them on the GitHub or something. For our idle, we just want the character to do nothing here, so we have null 3 times. For our heal entry action, we want to cast a healing spell, which we can just do by referencing our cast healing spell method down here without any brackets. If you add brackets, it won't work, so don't add brackets. Nothing for the update action, and a stop casting method for our exit action. And for our attack state, we want to draw a sword. Look at the target on update and put the sword away if we leave our attack state. Set up the transitions. We will now define a lambda function, which is another nice trick you can use in functional programming. It's not really clean, but if it's just for small functions, I would say you can do it. Otherwise, just use a normal method. Won't be much more effort. Let's start. Give ourselves some space here. Firstly, we want our method or our function, which we'll now define, to have no input parameters. So just write 2 brackets with nothing in them. Use this arrow with an equal symbol and bigger than symbol. And then just do a normal Boolean condition here. So in my case, we want health smaller than or equal to low threshold. So this is our transition condition, which needs to be triggered to go to the target state. Heal and null. Heal is the target state and null is the action which will be done when the transition is triggered. Same thing from going back from our healing state, so heal.when. So now we want a new time condition, which will trigger after 5 seconds. So just write new time condition and then is fulfilled. Then go back to idle and add health to our player. Okay, so now let's define some local functions and variables. To be specific, let's define some conditions. I'll call this one player close condition. So same thing as before, no input, arrow, then vector3.distance, target.transform.position and transform.position smaller than or equal to our close distance up there. There will be weird formatting in writer. I don't really use it. Then also we can just negate that condition. So not player close condition will be just not player close condition. Obviously we need no input and so on here. So brackets, arrow, not player close condition. Actually we need brackets here because it will evaluate the condition for us here and then negate it and return the value. So if we want it to be evaluated, we need the brackets. Okay, so now we can define the transitions for our attack state. So idle.when, player close condition, then attack, go to attack state, and no action for that needed. And attack.when, not player close, not close condition, go back to idle and just do nothing. Okay, so now we want to actually create our finite state machine. Actually, you should do this in a local field, so finite state machine, FSM. So we can just write FSM equals new finite state machine and our initial state will be idle. And then add all the states we just defined to our finite state machine. So add states, idle, heal, and attack. Then in our update method, we obviously want to take our finite state machine, which will give us all the actions, but we don't do anything with them right now. If we actually want to use these actions and execute them, use them by executing them, we need to do fsm.execute actions and then add fsm.tick. Yeah, that's all. So this blue capsule here will be our player, and this skeleton here will be our skeleton character. Let's switch to scene view. As you can see, the player is not close and he's well above our minimum health with 200 health. So he will just idle, just stand there, do nothing. As I move my player close, he will draw his sword, as you can see. Right there. Let me move out a bit. So he will draw a sword and also rotate to look at our player. Then as I go back, he will stop looking at my player and pull away his sword. And if I set his health to, let's say 10, he will start healing. Yeah, that's it. Thanks for watching. Subscribe to my YouTube channel if you want to see more CS videos.